Hello, grade 9. How are you today? I hope you all are safe and well. Today in chemistry lesson we will learn about making salts from acids and metals. We learned about acids and metals, reaction of metals with dilute acids, and we said the metals that react more vigorously with water can react with these diluted acids. So these acids and metals, when they react, they form something called salts. But also we can get hydrogen gas. So this is the product from reaction metals with dilute acids. Today we will learn more about it and how can we make a salt from this reaction. Open your books on page 200 and please grab your highlighter to highlight the main points. Making salts, acids and metals. So we can make salts in different ways, but now we will talk about how can we make them from acids and metals. What are salts? So look at these pictures in front of you. You have three kinds of salts, but what is the difference between them, and what are the similarities, or what's the thing that they have in common? These pictures show some salts. What do they have in common? So if you took a look over them, you will find them made of crystals. Okay? But they have something common. We have here copper sulfate crystals, manganese chloride crystals, and nickel nitrate crystals. So let's find out what's in common in them. The crystals are all samples of salts. A salt is a compound made when a metal replaces the hydrogen in an acid. So this is replacement reaction. Okay, the metal can replace the hydrogen in the acid, and the hydrogen will go as free gas. So in this case, will react with the other chemical and form salt. Different acids make different salts. So if we have hydrochloric acid with metal, makes chlorides because we have chlorine here. So the hydrogen will go out, and the metal will replace the hydrogen and combine or make a compound with the chlorine to form chlorides. Sulfuric acid makes sulfates. Nitric acid makes nitrates. So these are three types of acids that can make different salts. So chlorides are salts, sulfate and nitrate. So how can we make magnesium chloride here? First, you have to choose the reactants. You have different choices to use. You have to use hydrochloric acid, okay, to get chloride, and you have to choose the other product, the other reactant. So you have to choose something with magnesium. So are you going to use only magnesium metal or magnesium compound? Okay. Zeta wants to make magnesium chloride. She needs two reactants. One is hydrochloric acid, of course, because we want magnesium chloride, so we need to use hydrochloric acid. The other reactant must include magnesium. Zeta could use magnesium metal, or magnesium oxide, or magnesium carbonate. She decides to use magnesium metal because she wants hydrogen and magnesium chloride. So there is a pattern in the reaction of metals with acids. We talked about this before in reactions of acids with metals with acids, and we said the metal reacts with acid to form hydrogen gas and salt. So there are two products, a salt and hydrogen. So when magnesium reacts with hydrochloric acid, the products are magnesium chloride and hydrogen. This is the word equation for the reaction. Magnesium plus hydrochloric acid, give us magnesium chloride plus hydrogen. And try to use this word equation to test yourself to make it as a symbol equation, just like a small test for yourselves. The chemical reaction. So when you want to use this metal with the hydrochloric acid, you have to choose equipments and you have to measure amounts of the acids and the volume of the acids and the amount of the metal, and set your apparatus on how to do this. So Sita measures out 25 cubic centimeter of dilute hydrochloric acid. She uses a measuring cylinder. Do you remember about the measuring cylinder when we used it in the lab? We said that the measuring cylinder can measure accurately more than the beaker, because beaker we have like we have a scale that is not very accurate. We have known volume, but the measuring cylinder can measure the small amount. So here she measured in measuring cylinder, and you have to focus here because this can be a good question. A measuring cylinder measures smaller differences in volume than beaker. So Sita pours the acid into a beaker. Then, when she measures the acid with her volume with the measuring cylinder, she poured it in a beaker. Why? Because we are using beakers to make the reactions, okay, to make it easy to see the reaction. Sita adds a small piece of magnesium ribbon to the acid in the beaker. The magnesium reacts with the acid and bubbles of hydrogen gas form. After a few seconds, the bubbles stop. All the magnesium has reacted with the acid. So here, this is a sign of one of this reaction sign to see bubbles or to hear fizzing, okay? So she took a magnesium ribbon and she placed it in the hydrochloric acid, diluted hydrochloric acid, and she saw a hydrogen bubbles. This is the hydrogen gas going out, escaping out. And the magnesium ribbons start to be smaller and smaller until no magnesium left. Then she adds another piece of magnesium to the acid. She continues to add magnesium until there are no more bubbles. So what's the meaning of this? When she started to use a magnesium ribbon, one magnesium ribbon, okay, she found it like disappeared and no more bubbles. Then she added another piece, and then she added another piece until the hydrogen gas stopped, okay? So in this case, that means all the magnesium replaced the hydrogen in the acid. So it means this quantity or this volume of this acid needs special amount, like a specific amount or volume of magnesium to react with. A piece of magnesium remains. It has not reacted because all the acid has been used up. So this also could be a question. So now how can we separate the magnesium chloride from the mixture? This is a mixture because we have water and we have magnesium chloride. So how can we make it salt? Because we said all this just to make a salt, magnesium chloride salt. Sita's beaker contains a mixture. The mixture includes magnesium chloride solution and solid magnesium. So we still have this solid. So first, to move this solid, we have to filter. Just filter the mixture and you get the solution. Then how can we take this compound out of the mixture? How can we take the magnesium chloride from the mixture? Think about evaporation. In grade 8, we studied about how can we form copper sulfate crystals. So we started to make a solution, and then we start to evaporate. So this is what she's going to do. Sita wants to make pure magnesium chloride, which is salt, crystals. First, she filters the mixture. This removes the solid magnesium. Next, Seta pours the magnesium chloride solution into an evaporating dish. She heats the solution. Water evaporates. When the water starts to evaporate, about half of the water has evaporated. She stops heating and then she placed it in a warm place and left it for many days. After many days, she found crystals of magnesium chloride. So a few days later, Sita looks into the evaporating dish. She sees beautiful white crystals. She has made her salt magnesium chloride. So this is how can you make a salt. You have to react the reactants, get the product, and then separate the mixture from the salt from the mixture with any possible way you can use or proper way. So here in this beaker, okay, in this flask, she poured the mixture in the funnel here, and then she got the mixture without the ribbon. Then she poured it in evaporating dish. Half of the of the water evaporated. She left the solution in a warm place, and then she got crystals after days. Now, guys, let's see the summary of the lesson. Making salts, acids, and metals. Make salt from acids and metals by reacting an acid with excess metal, then filtering to remove unreacted metal, last thing, heating to remove water. And this is the equation. After testing yourself, you can see the result here, if you are if you succeeded or not. Magnesium plus hydrochloric acid will give us magnesium chloride plus hydrogen. So this is the symbol equation, Mg plus HCl, MgCl2 plus H2, and this is for balancing, because here, as we studied in balancing equations, we have 2Cl, 2 hydrogen, so we have to write here big 2 for, that means 2 hydrogen and 2 chloride in this way. Okay, in this case we have the same percentage of the quantities of reactants and products. Okay, this was all about making salts. I hope you understood the lesson. If you have any question, write it down, and don't forget the yellow box. Okay, see you soon, and please stay safe. Bye bye.